Hello everyone, today we will hear a speech for non-technical specialists. R.Kotov is going to talk about database design fundamentals. Roma, hello, you can start.
Yeah, great. Hello, everyone. So uh, today's topic is the database design fundamentals. Yeah, and first we'll start with the entity relationship model. Yeah, I will tell you what is the entity, what is the relationship, and how these two things are connected. Then we will move to the physical and logical data models. We will try to find out what is the difference between these two. After that, we will switch to the normalization and see in action three normal forms. And then we will go to the normalization. So that's the plan. Yeah. And let's start with the entity. So we need to define what is the entity. And uh, it can be literally everything. Yeah. Usually it's the real world object. For example, if we're going to store some data about the flights, so we'll have the planes entity, we will have the pilots entity, airports, and whatever. So whatever can be an entity. So there is the infinite variety. Yeah. And when we have more than one entity, probably we can define the relationship between these two, and we'll start with the easiest one. The easiest one is one-to-one mandatory relationship. Uh, that means for each item of entity one, there is only one item of entity two, and it's required. Yeah. For example, entity one can be a worker. Yeah, and if we have the company where the workers have to work on their laptops, I mean that were given by the company, yeah. So there must be only one laptop for each worker, yeah, and each worker can have only one laptop, yeah. Hope that's easy to understand. And the second type of relationships is one-to-one optional, yeah, and in this case, so there is a scenario when there is no entity two for the entity one, yeah, and for example, um, uh, the entity one can be again the worker, yeah, and the entity two can be worker's place, yeah, and sometimes people can work uh, remotely, and so there will be no working place in the office for them, yeah, and you can see the difference, yeah, because when we deal with the optional one, so there is a circle, yeah. Let's go next. Next kind of relationships is one-to-many optional. So that means there can be multiple items of entity two for entity one. Let's say entity one can be the people, and the entity two can be the cars, yeah. And each person can have multiple cars, yeah. But also, and each car belongs to only one person, yeah. And also there can be a scenario when one person have no cars, yeah, because it's optional. And the next one is one-to-one required, yeah. And in this case, there must be at least one item of entity two for entity one, yeah. And for example, uh, the entity one can be a group in the university, and entity two can be the students, yeah. And each group has multiple students, and the and each student belongs to only one group. Yeah, I hope it's clear. So we can go next. Yeah. And the last relationship that I'm going to show you is many-to-many relationship. And for example, the entity one can be users, and the entity two can be the notifications. And each user can have multiple notifications, and each notification can be sent to multiple users. Yeah. As the examples that I've already told you about the group students relationship. Yeah, and here we see some part of the schema probably for the university. Yeah, so we see the faculty. Faculty has multiple groups. Yeah, each group belongs to only one faculty, and the same for the students and groups. Yeah, so each group has multiple students, and each student belongs to only one group. Yeah, there is one more example with the, let's say that's the part of the schema for the let's say outsource company. Yeah, there is a department. Each department has multiple developers, and each developer can have multiple projects, and vice versa. That each project can have multiple developers working on it. And here we see the optional many-to-many. That means there can be a developer, let's say, on the bench with no project, and also there can be a project, let's say, closed, that and there are no developers working on it. Yeah, and we move to the logical design, logical schema, and so things that you just saw here, that's actually a part of the schema, or the schema, or the whole schema. So, and but if we're talking about the logical design, we do we just show the entities, the relationships between them, and also we show the fields of it. But the important thing that we do not know the exact types of the fields, and we do not know with which database are we working with. Yeah. So here you can see the same entities. Yeah, and you can notice that we do not know the type of the, let's say, faculty ID, or type for the first name field. Yeah. And we create one-to-many relationship with the foreign keys. Yeah. And quite same for the department developer project schema. And we can move to the physical design, and there's a difference between physical and logical design. That when we create the physical schema, that means that we know the database that we're working with. Yeah, and we provide more details. We know the exact type of the fields, and we know the realizations of the relationships. So we know the specifics of a particular database. So here you can see the same entities. So faculty, group, and student. And now we have the types of the fields. So the ID is going to be a number, center name is going to be a string, and whatever. Yeah. And that's the source code that I used to, yeah. And here you can see that I use the engine DB. Yeah, that means that I'm working with the, engine in a DB. That means that I use the MySQL. So I know the database that I'm working with. And that's the second example with the department developer project schema. And here you can see the difference, because first of all, we have the types of the fields. And the second one, we have additional table named project developer, additional, let's say, entity. And that's how we realize the man-to-man relationship between developer and project. Yeah, so we can move back, yeah, and see that here we didn't see uh, the fourth table, yeah. And when we move to the physical schema, yeah, so there is the project developer table when the project ID and developer ID are stored. Yeah, and that's the source code for it. Yeah, and again, you can see that these tables were created for the MySQL database. Yeah, we can move to the normalization. Yeah, and what is the normalization? Yeah, that's the process when we remove the redundancy of data. So, and we said that, so we define redundancy as is the case when we store more data than necessary. And if we go with normalization, it helps us to increase disk space and get rid of anomalies of activation, upgrade, and deletion. Yeah. So nothing important here, maybe. So yeah, we usually eliminate the redundancy by composing the relationships. Yeah. So maybe for this moment, some things are unclear for you, but we'll look at the examples and things gonna uh, become better. So there are different normal forms. Yeah. So about eight or maybe more. But for today, I'm gonna only tell you about the first three normal forms. Yeah, and the first one is so named like the first normal form, and each normal form has its conditions, let's say requirements. Yeah, and for example, if our database satisfies the conditions of the first normal form, we can say that our database in the first normal form. Yeah, so we can read the uh, conditions. Yeah, so it says that each table cell should contain only one single value. Yeah, and there should be no duplicates. Yeah, so we can see at the example. Yeah, so at the left side here, we can see the table before the normalization. Yeah, we can see that David and Martin have multiple hobbies. Yeah, it's actually not a problem to have multiple hobbies. Yeah, but as the first normal form says, that each table should contain only each table cell should contain only one single value. Yeah, so there are what are we going to do? We're going to split it, and now we have only one hobby for each row. Yeah, so we have some maybe you want to say that we have the duplicates, like we have two rows with the debit. Yeah, but that's not a big deal. It's fine because the hobbies for the same names are different. Yeah, we can go to the second normal form. Yeah, it builds on the first one. It means that the second normal form, so the same conditions for the first works for the second. Yeah, so it has a primary key, and all attributes depends on the primary key as a whole, not on the some part of it. Yeah, maybe again something unclear for you, but we'll look at the examples. Yeah, so we see the table, and here we have the column name, project, and project manager. And if we will look closer, we will notice that actually the project manager name doesn't. So first of all, the first thing that we need to do is if we wanna um, our database to satisfy the second normal form, yeah, the first thing that we going to do, yeah, is add the primary key. Yeah, yeah, we at the primary key, yeah. But for now, if we look closer, yeah, we will see. So by the way, there's the composite, yeah, primary key. So developer ID and project ID, yeah, these two columns, that's the parts of the primary key. And if we look closer, we'll notice that a project manager name doesn't really depends on the, let's say, developer ID. So it only depends on the project ID, yeah. So uh, it depends only partially, not on the whole primary key. So, and the thing that we're going to do, so to make our database satisfy the second normal form is splitting, decomposing, yeah, decomposition. So for now we have three tables. We have the table that only stores data about the developers. Yeah, and the right one stores only data about the projects. And there is the table that stores developer ID and project ID. And as you already saw, we need the third, we usually need the third table, yeah, to define the man relationship, yeah. So we can go to the third normal form, yeah, and it builds on the second. And the only difference, yeah, comparing with the second one, is all attributes depends directly on the primary key, not on other attributes. So there can be a transitive dependency, yeah. And what is the transitive dependency, yeah? Uh, so we will try to answer this question, and everything gonna be clear, yeah. So there is a table, yeah, and we see some information. We see some information about the employee, yeah, employee ID, name, zip, state, and city, yeah. And if we look closer, yeah, we will notice that actually employee city depends directly on the state, yeah, and state depends directly on the zip, yeah, and only so employee city depends on the employee ID only in the transitive way, yeah. So, and what are we going to do again, um, as in the previous normal forms? So we're going to make the decomposition, yeah, and here we separated the uh, information about the employee, yeah, uh, and we do not store the redundant data about his location at the same table, yeah. So we have uh, another table for storing the information about location, yeah. So we store the zip, state, and city in a different table, yeah. And also we can use this zips, I mean this rows from the right table uh, for other users, yeah. And so we will avoid some duplication, and we will make our so there will be more free space on the hard disk, yeah, when where our database is stored, yeah. And as you could notice, so when we perform the normalization, the number of tables increases. That means, so you could see it here, yeah. So we had only one. As a result, we have two, yeah. Here we have, yeah, also only one table. As a result, we have three, yeah. And to collect the data for the database query, we need to perform the join. Join, that's the operation uh, of the SQL, yeah, SQL, I mean, and that's really expensive operation for the system. And when we have to perform huge amount of joins, our queries become more slower, yeah, and we have to wait more time. And it's really it affects our database performance in the bad way, yeah. And the thing that we can do about it, we can go with denormalization, yeah. And then denormalization is a technique in which we add redundant data to one or more tables, yeah. And this can help us avoid costly joins in a relational database. So sometimes the process of so there are different techniques of denormalization, but sometimes the denormalization is just the opposite uh, actions to the normalization, yeah. And so we can have a talk about the advantages of it, yeah. So it makes our queries faster, yeah. And when we have less tables in the database, it makes our database schema more readable, yeah, and easier to understand, like what happens, understand the connections between the entities, yeah. And the disadvantage of the normalization is uh, so sometimes data can be inconsistent, yeah, and sometimes updates and inserts are more expensive, yeah. And so we go back just to redundant data. And so probably now if you think like Romeo just said, so there are some advantages and disadvantages for the normalization, for denormalization, what is good, what is bad, yeah, what is good, what is evil, yeah. And what shall I go with to design the database, yeah. And the solution is yeah, so uh, it should be perfectly balanced, as all things should be, yeah. So we cannot sometimes we cannot only follow the normalization, yeah. And so we usually cannot only go with the normalization, yeah. And I think that we should do is to monitor the performance of our system, yeah. If we notice there are some queries that are slow enough, and if we find out that the problem was caused by the uh, huge number of joins, yeah. So probably we shall go with the normalization, yeah, and decrease the number of joins, so decrease the number of tables, and the query is gonna be faster, yeah. And vice versa, yeah. And if we have some troubles with the data consistency, or insert or update operations are so expensive, yeah. And probably we shall go with normalization, yeah. And the important thing that you need to identify these two things as a tool, as tools, yeah. And use it when it's yeah, appropriate to use, yeah. So I think that um, that's all from my side, yeah. Hope this information was helpful for you, yeah. And now I'm ready to ask your questions if you have any. Yeah.
One, thank you very much. Guys, don't afraid to ask many questions, even in English.
I hope everything was clear, so no questions from the audience.
Roman, for me, everything was clear. So
Yeah, that's great.
yes. So you have just one like.
Yeah, that's great.
We need two more likes. I guess we don't have questions. So Roman. Thank you, for your speech. And thank you, everyone, for coming. Have a
Yes,
great
Victoria,
evening.
is this the first meetup in English
What?
in our program for non-technical employees?
No, it's first for me,
Oh,
for
great.
non-technical.
So, Roman, congratulations and thank you.
Yeah, thanks for coming. Yeah, thanks for having me. Yeah.
Have a great evening. Bye.
Yeah, you too.
Bye.